Hello everyone. In this session, we'll discuss about instruction set of 8085 microprocessor. So before going with the instruction set, first let us understand what a instruction is. So instruction is nothing but a command given to the microprocessor. It is a command given to the microprocessor to perform a specific task. So how do you give the command to the microprocessor? We give the command in the form of zeros and ones, nothing but binary pattern. So we say instruction is a binary pattern given to the microprocessor to perform certain task. Now 8085 has 246 instructions. 8085 has the total number of instructions in the 8085 microprocessor are 246. Instruction consists of two parts, opcode and operand. So for example, if you take add B. So what is add telling us? Add is telling us what is the operation to be done. So the operation to be done is add. So what are the operands? Means on which data it has to perform. It has to, one is an implied register which is A register and the other one is B register. The content of A register plus the content of B register and the result in A register. So instruction always has two parts. One is what is the operation to be done, nothing but your opcode, and on which operands the opcode has to be performed, nothing but your operand. It might be a register, it might be the data, or it might be the memory locations. Next, classification of instruction set. So the classification of 8085 instruction set is divided into data transfer group, arithmetic group, logical, branching and control instructions. In this session, we will discuss about the data transfer group of instructions. So first let us understand what are these data transfer instructions. So these instructions means these data transfer instructions, they move or copy the data. They move or copy the data from source to destination. So this may be between the registers or this may be between memory and registers. So data transfer group, what does it do? It moves or copies the data from the source to destination, that is between the registers, between the memory and registers also. So first move. Move instruction copies the data from source to destination. That is, this instruction copies the contents of source register given as RS to the destination register RD. If one of the operands is a memory location, in the second and third example, if one of the operand is a memory location, so memory location means there should be an address. So M always refers to the address, and in 8085 it is of 16-bit, and always M refers to the HL pair. The 16-bit address will be stored in the H and L register pair. So always M refers to the memory location address, and that address will be in the HL pair. So as you see in the second instruction, move M comma RS means the content of the source register. The content or the data present in the source register will be moved to the memory location address specified by the HL pair. Let's see some examples. Move C comma B. So before execution, assume that C is anyhow a destination register. We need not bother about the content of C register. It may be some XX. Let the content of B register be 05. Let's see few examples. So the first one is move C comma B. So before execution, let C be some XX. We are not bothered about the value in the C register, and B be some 05H. So after the execution, after the instruction is executed, what does the instruction do? The content of B register are copied into the C register. This is your source and this is your destination. So after the execution, the C register will have 05H and B register 05H, because the move instruction will only copy the data from the source to the destination. The move instruction will not alter the data in the source register. The source remains same. Yeah, let's see the second example. Move A comma M. So as I told you, M always refers to the HL pair. So assume that 2030 is the memory location. M is referring to the memory location address 2030, wherein assume we have some data AA. And now the H has to be 20, L has to be 30. HL pair. We store this address in the HL pair. And accumulator, there might be some random data present in the accumulator. So after execution, what does the instruction do? The data pointed by the memory location, the data pointed by the memory location in the HL pair will be copied into the accumulator register. And what is that? AA. AA will be copied into the accumulator register, and your HL pair, it would be the same, 20, 30. Because the source will never get altered. Only the destination will be altered. So this is about the move instruction. Next is your move immediate. So move immediate, the first one, move immediate. These are the templates. Move immediate RD comma data, and data is of 8-bit size. And move immediate M comma data, again data is of 8-bit size. So the 8-bit data is stored in the destination register. So the 8-bit data get copied into the destination register RD, or in the second, the 8-bit data is copied into the memory location specified by the contents of HL register. Specified by the content of HL registers. So let's see some examples. Move immediate A comma 20H. So move immediate A comma 20H is before execution and after execution. So before execution, usually there might be any value, but after execution, so what does this instruction do? 20H is the immediate data available in the instruction. So 20H will be copied into accumulator register. So after execution, A will have 20H. Let's see the second example. Move immediate M comma 20H. So before execution, let HL pair. Always remember the M refers to the HL pair, and let the HL pair have 30, 50. 3050. H will have the 30, L will have the 50. So after execution, so what, as per the instruction, what happens? 20H is the immediate data available in the instruction, and it should get copied to the memory location whose address is given in the HL pair. So in 3050 memory location, the data gets copied. What is the data? 20H. So 20H get copied into 3050 memory location. And the HL. So HL will be same with 3050. So this is about the move immediate instruction. Next, load accumulator. Load accumulator 16-bit address. Now here the contents of the memory location specified by a 16-bit address. So this 16-bit address, assume it is the memory, and you know that in 8085 16-bit address, so 00, this is your address range, 4 zeros to 4F. So the content of the, assume that here you have given some address like this. So the content of a memory location specified by the 16-bit address in the operand are copied to the accumulator register. So whatever may be the content of the memory location, it gets copied into the accumulator register. So the content of memory location copied into the accumulator register. And the content of the source are not altered. Source means what? The content of the memory location will not get altered. So let's understand with an example. LDA 3000H. So before execution and after execution. Before execution, assume that in the 3000 memory location there is some data 30, some 30H, because each location can store only 8-bit of data. Because each memory location can store only 8-bit of data, we are assuming that 30, because it is a binary coded decimal BCD format, and A may have any previous value or any random value. So after execution, what happens? The content of the 3000 memory location get copied into the accumulator register 30H. 30H get copied into the accumulator register. And what will be the content of the 3000 memory location? The source will not get altered. It will be same. So this is about the LDA instruction, and this LDA instruction we use it in direct addressing modes. So always in the direct addressing mode, we store the data in the memory, and the address of the memory location will be the part of the instruction. Yeah, next instruction, LDAX, load accumulator indirect. So always remember, X indicates a register pair. It is not one register. It is register pair, means two registers. For example, it might be B, C. It might be B and C, or it might be D and E. Let me write down B, C or D, E. Anything. So the content of the designated register pair, whatever given register pair, point to a memory location. So usually again the data will be in the memory, and the memory location address, the address of which will be given in the register pair. Because the address is of 16-bit address, we need two registers. We need two registers. One register is not sufficient. So we either use the BC or DE pair. This instruction copies the contents of the memory location into the accumulator register. So I can also say it as the content of the memory location will be copied into accumulator register. The contents of either the register pair or the memory location will not be altered. So after the execution also, the register pair value will not be changed, or the content of the memory location also will not be changed. Yeah, let's understand with an example. LDA x D. As I told you, X always indicates the register pair. So D is not alone here. D and D register is nothing but yeah, D and E. As written here, D is DE pair. So LDA x D. Assume that 2050 is the content of the DE. Means 20 in the D register, 50 in the E register. And also assume that in the memory location 2050 there is some data 0AH. So after execution, what happens? As you know that DE from the instruction, DE is a register pair which is going to hold the address of the memory location. Now the content of the memory location whose address is available in the DE register will get copied into the accumulator register. So now the DE register, what does the DE register consist of? 2050. So the content of 2050 is 0A. So 0A gets copied into the accumulator register. And as told, the source will not get altered. So the DE contents will not change. And also 2050 also, the 0AH remains the same. Next one, LXI, load register pair immediate. So this instruction loads the 16-bit data into the register pair. So directly the 16-bit data is available in the instruction, or we can also see it as it is part of the instruction, and it gets copied into the register pair. Example LXI H, 2030. So before execution we need not bother what is there in the HL, but after execution your HL pair. So this is your 2030. So H gets copied with 20 and L gets the 30. So this instruction may be used to load the register pairs. Always again, X indicates the register pair. I indicates the immediate addressing. Yeah. Next one, LHLD, load HL registers direct. Load H and L registers direct. And the template for it is LHLD 16-bit address. Now this instruction copies the contents of the memory location pointed out by 16-bit address into register L, and it copies the contents of the next memory location into register H. So let me write down. Whatever the 16-bit address which is given in the instruction, the content of this address will get copied into L register. Content of this gets copied into the L register, and the 16-bit address plus 1 get copied into the H register. So So let's understand this. LHLD 3040. So before execution, assume that in the memory location 3040 we have data some AA, and in 3041 we have some data BBH. So after execution, see here, as I told you, the content of the 16-bit address get copied into the L register. So the content of the 16-bit address 3040, what is the content? AA, will get copied into the L register. So AA get copied into the L register. And next, the 16-bit address plus 1. 16-bit address plus 1, the content of it get copies into the H register. So 3040 plus 1, nothing but 3041. The content of this memory location, which is BB, gets copied into the H register. So this is how we understand the LHLD. It stores the 16-bit, the content of the memory location 16-bit address into the L register, and plus 1 it loads into the H register. Next, STA, store accumulator direct. Always whenever you see the direct, you need to understand it is a address. It is a memory location address. What is its template? STA 16-bit address. Now the content of the accumulator, it is reverse of the load. In load we were loading the accumulator register. Now we store the accumulator register content into the memory location. The content of the accumulator is copied into the memory location specified by the operand. So for example, STA 2000. So before execution and after execution. So before execution, assume that the accumulator has some 20H in it. So what does the instruction do? It copies the content of the accumulator into the memory location address which is given in the instruction, which is 2000. So A will have the same 20H, but the content of your memory location 2000 will be copied with the content of the accumulator, nothing but 20H. Next is your STAX. Again, X indicates register pair. So store accumulator indirect. So what does this instruction do? The contents of the accumulator, is copied into the memory location specified by the contents of the register pair. Now register pair is going to have a memory location address. So the content of accumulator is copied into the memory location whose address is given in the register pair. Assume that this is the memory location whose address is given in the register pair, and register pair can be any pair, BC, DE or HL. So let's see the example. STAX B. B indicates it is, because it is a register pair, it is B and C. So before execution, let the contents of accumulator be some 5BH. And the register B and C, you know that register B and C carries the memory location address. So let it be some 8000. After execution, so as per the definition of the instruction, the content of accumulator should be stored in the memory location whose address is specified in the register pair. So 8000 should be copied with the content of the accumulator register, nothing but 5BH. We will continue the data transfer instruction group explanation part 2 in next lecture. For more videos on 8085 microprocessor and programming, you can refer to the playlist.